Good morning, everybody. It is math time with Machado. I guess I probably shouldn't say good morning because it's probably, I don't know how many of you are watching these videos first thing in the morning. Probably not many, but just in case, good morning. Today what we're going to look at is properties of logarithms. Now, if we remember what we were looking at last section, we were looking at logarithmic functions and seeing how they work. We were able to remember that if I had y is equal to log base a of x, that can turn around into a to the y is equal to x, right? We looked at that relationship between our logarithmic functions and our exponentials. And what we're going to look at today are some really kind of cool ways that we can use the properties of these logarithmic functions to be able to combine things or expand them and make them a little bit easier to figure out. If we were in class, this would be a super exciting day for me because this is the kind of math that you guys know I really love and get really excited about, but you're not here, so I'm going to try to be excited all by myself. So, one thing I want to remind people of, and I don't remember if I said it in the last video or not, is remember that if we've got a log function like this, right? This is called our base of a log function. And if, like let's say I've just got log of 2, notice there's no base. All right, if there is no base, then if there's no base listed, it's almost like there's that invisible 1 that goes in front of, an x squared, then, my a is 1. It's the same thing, except for if there's no base, it's always going to be a base 10. Okay, so if you look at your calculator, you probably notice that there's a log button on it. Here, I'm going to put mine up here. All right, there's this little log button. All that means is log base 10. So later on today, we're going to look at how we can actually use that button to be able to use our calculator to get decimal approximations, which you probably have already looked at a little bit with Mr. Thompson, but not necessarily for bases that are not 10. So let's go ahead and let's see what we can do for some of these. The first property that I'm going to be looking at is, I want to use the same term for what they call it in here. Oh, they don't have a name for it. But the first property is that log base a of 1 is equal to 0. Doesn't matter what my base is. And if we think about it, this does make sense because anything to the 0 power is equal to 1. So that's going to be our first one. And then the second one is that log base a of a is equal to 1. Once again, that should also make sense because anything raised to the first power is just going to be equal to the anything. So for a couple of examples, if I've got log base 13 of 1, well, I've got a base to some exponent that equals 1, I know that it has to equal 0. If I've got log base 9 of 9, well, 9 to what power is equal to 1? Well, that's just going to be a 1. As we look through, there are going to be times where we can use this property to help us simplify, which is kind of fun. So the next thing that we're going to look at is, it's called the inverse properties. Now remember that a logarithmic function is an inverse of an exponential function, right? It undoes it, just kind of like a square root undoes a square, right? If I have x squared and then I take the square root of it, I'm left with plain old x. That same idea is going to happen here. So if I have a and it's raised to the log base a of x, that's going to be equal to x. Notice I've got a and a here, right? I have the same base. So if I've got a log up here in my exponent with the same base, this whole part here cancels itself out. And I'm just left with x. Likewise, if I've got log base a of a to the x, Well, this whole part here just cancels out, and then my x is left all by itself. So if I've got, as an example, let's say I've got 5 to the log base 5 of 15, right? All of this whole part is going to cancel out. All of it's gone, and I'm just left with a 15. Or if I've got log base 7 of 7 to the 4th power, well, those are going to cancel out. I'm going to just be left with that little 4 hanging out up at top. Okay? All right. The next one, these are where they get really fun, because then we can start combining things and separating them, and it just gets to be a lot of fun. So if I've got log base A of m times n, right? What operation is going on in here? This is multiplication, right? So when I've got two things being multiplied inside of my log, I can use the product property of logarithms, and I can actually expand this. Now, if we think back with our exponents, right? If I had x squared times x to the 9th, remember, if I was multiplying with my exponents, I ended up adding them together, right? Addition is the operation that I did here. And all of our log properties work the same way. So if I'm multiplying inside of my log, it's like I've got this type of situation here. So when I expand it, I'm actually adding them together. Okay, so if I have a product inside of my log, it turns into addition. Then with our quotient property, quotient, I hope we remember what that word means, right? If this is a product, the next thing that I'm looking at is a quotient, right? That's going to mirror what happened if I had, say, x to the 7th divided by x to the 3rd. The operation that I would do with these would be, oops, not a 7, sorry. X to the 7 minus 3, right? Subtraction is that operation that shows up here. And it's the same thing that shows up here. Base A to the n. So let's look at a couple of examples and see how these play out, because we can use it to expand, like we're going to here for a few minutes, and then after some more of these examples, then we'll look at how we can go back and, instead of expanding, see if we can condense to get it into one logarithm. So let's look at something like this. Log base 3 of 3x. Right? This operation right here is multiplication. So what I can do to write this as a sum of logs is I'm going to have log base 3 of 3 plus log base 3 of x. Now, just like whenever we're dealing with fractions or anything like that, we always want to simplify whenever possible. So I see this, and I'm thinking back to one of those first things that we looked at. When we first looked at these properties, the very first ones that we looked at looked like this, right? I've got log to the base and that same exponent. So the question that's being asked here, or the same result, sorry. The question that's being asked is 3 to what power is equal to 3? Well, that's going to equal 1. Isn't that cool? Okay, let's look at one more with multiplication, and then we'll look at one that's got some division in there. Oh, 8xy. So I've got log base 2 of 8xy. So this right here, even though there's more than one thing being multiplied with another, I have three things. I can still separate it out. So I've got log base 2 of 8 plus log base 2 of x plus log base 2 of y. So these are all the same base, because we all started off with the same base, right? This one right here is something special though, right? Log 2 to what power is equal to 8? Remember, that's all that this question is asking. 2 to what power is equal to 8? And that's 3. Because remember, 2 cubed is equal to 8. So I've got 3 plus log base 2 of x plus log base 2 of y. Nothing else there simplifies, so this is my answer. Let's look at one with division and see what happens. Let's look at log base 2 of 5/4. Okay, so for this one, I'm dividing, which means I'm going to subtract. I take my top one first, so log base 2 of 5 minus log base 2 of 4. And once again, this is exciting, right? 2 to what power is equal to 4? Right? That's the whole question that's being asked there. And so 2 squared is going to give me 4. So it's like that x has to be a 2. 2 is going to be the answer to that. So I've got log base 2 of 5 minus 2. Ooh, let's look at this one. I like this one a lot. Mainly because I mentioned something at the beginning of the video, but we haven't really seen it show up yet. Uh-oh. Ah! What are we going to do? There's no base. Eek! Oh no! What are we gonna do? Remember, if there's no base, my base is what? 10. So I'm gonna rewrite that with a base, and for some of you it might be helpful for whenever you don't see a base, just throw a base in there. Make it a 10 so that you know what it's supposed to be, and that'll make it easier when you're expanding these. So I've got log base 10 of 10 minus, right, because it's division, log base 10 of y, log base 10 of 10. Remember, this is one of those ones where 10 to what power is equal to 10? Oh, it's just going to be a 1 minus log y. Now you could, if you want to, you can keep that 10 in there. That's not something that I'll mark you down on or anything like that. You can have it there, but notice that the answer could also be written like this. So say you're taking the SAT or something like that, and they give you something that looks like this. Even though there's no base, it would still be correct. Okay? All right. The very last property that we need to look at is dealing with exponents. Where's my, there we go. So it's called the power property. And that's where if I've got log base a of m to the p, right? There's some sort of an exponent going on there. What I can do is this exponent gets brought down in front. So it's going to be p times log base a of m. So let's look at an example of this so we can kind of see how this works. Let's say I've got log base 5 of 4 cubed. Okay? This is an exponent up here, so I can bring it down in front. And I've got 3 times log base 5 of 4. Okay. Let's look at another one. Let's look at log base 2 of 8 to the 10th. Right, so I can bring this down over here. So I'm going to have 10 log base 2 of 8. Ooh, what happens here? Right, log base 2 of 8. 2 to what power is equal to 8? Remember, that's the question that we're asking. So I've got 10 times just a plain old 3. So my answer is 30. We can use these properties to help us simplify, which is really fun. Okay? So that's all of the properties for this. We're going to look at some more examples here in a second, but I'm going to go ahead. I've got this nice paper right here where they're all written out. These are all of the different properties, so I'm going to leave it here for a moment. You can take a picture if you'd like. That way you've got, them written down, or you can pause and get these into your notes, which I would actually recommend more, is push pause and write these down. That way you've got them handy. You can just flip back in your notebook and you can continue to use them, because we are going to be using them both in this lesson and in the next one to help us solve more complicated equations. All right. Speaking of complicated, see, this is the part that gets me really excited. I love these things because you can take something that's complicated and turn it into its simpler parts. So I'm going to show you one here because it's a lot of fun. So let's say I've got log base 4 of 2x cubed y squared. Right, this is a big complicated looking thing, but what we can do is we can actually separate it out into its pieces. So that way we can simplify out whatever we can. This right here, I've got log base 4 of 2 plus log base 4 of x cubed plus log base 4 of y squared. So notice all that I did was just separate these out into its individual pieces using which property? The product property. Okay, now I can take and I can use the power property to bring those down in front. So this is going to be a 3 log 4x plus 2 log 4y. But this one's kind of special. This one is actually something that I can simplify. Remember, the question that I'm asking is 4 to what power is equal to 2? Ooh, I have to take the square root to get there, right? Remember, a square root is just a power of 1/2. So I was able to take this piece right here and then break it down into all these pieces, simplifying as much as I could. Let's look at another one. Let's look at this one. Ooh, this one's fun. Log base 4 times the 5th root, all of this stuff's in the 5th root, 2y cubed z squared. All right, so this one, wowzy, that's a big thing, right? So the first thing that I want to do is, we haven't really talked about dealing with radicals inside of logs because we don't have to. Isn't there another way that I could write this radical? This radical does not have to be this weird root symbol thing. Instead, we can rewrite it as a fractional exponent. Remember, so anytime that we see a radical, we can just change it into that fractional exponent, because if I've got an exponent in there, I know how to deal with it. Right? I can take this, I can get rid of this power first, so that way I'm dealing with something that's a little bit easier to deal with. Oh, not 1/2, 1/5, sorry. 1/5 log base 4 of x to the 4th all over 2y cubed z squared. Right? So all of this stuff is still inside of my log. So what I can do is I can start with my quotient property, right? And as I'm looking at it, 1/5 is going to be multiplied by everything that's inside there. So I'm going to have 1/5 log base 4 of x to the 4th minus log base 4 of 2y cubed z squared. Okay. So here I can deal with my exponent, right? So I'm going to have 1/5 times 4 log base 4 of x. Here I can separate this. I have to remember that this subtraction sign goes to everything that comes afterwards, right? It's minus this whole thing, so if I separate it, I'm going to end up having to distribute it, so I want to get those parentheses there. I'm going to have log base 4 of 2 plus, and then I've got log base 4 of y cubed, oops, plus log base 4 of z squared. Okay. Now I can keep simplifying in here, right? I've got 1/5 times, I've still got my 4 log base 4 of x, that still is the same, right? And then I'm going to be able to simplify this, right? We just looked at one that had this, and so I've got minus 1/2, minus, I can bring my 3 out in front, 3 log base 4 of y, and then minus, remembering, because I have to distribute that across, minus, I can bring my 2 out, 2 log base 4 of z. Oops. So if I want to, I could put all of these over a 5, or I can just leave it with this 1/5 out in front of it. That's fine too. So that one is as expanded as we can. Sometimes it's really helpful to expand it if we can. Other times, we might want to condense. Okay, so if I want to condense, I might be looking at something like this. Log base 4 of 3 plus log base 4 of x minus, oops, that's a really big O, log base 4 of y. Okay, so I can go from left to right, and I can use my properties to condense this. Here I have addition, right? I'm going to go back to my property page. Where did I set it? Here it is. I have addition, so if I look at my notes here, I'm looking to condense, so I'm starting over here where they're separated out. That's going to be multiplication. If I have subtraction, that's going to show up as division. So here I can condense these. I'm going to have log base 4 of 3x minus log base 4 of y. Log base 4, this is subtraction, so this is going to be division of 3x divided by y. Isn't that beautiful? I love the way that you can start off with something really big, and it gets nice and simple as you go. Let's look at another one. Let's say I've got 3 log base 2 of x plus 2 log base 2 of x minus 1. Ooh. Well, let's see what we can do. I can start off, I've got this number out in front, so those are going to pop up here because those become exponents, right? So I've got log base 2 of x cubed, right, because my 3's up there now, plus log base 2 of x minus 1 squared. All right. So now, as I look at this, I can combine with my addition, right? I've got my product property, so I've got log base 2 of x cubed times x minus 1 squared. All of that is inside there. And that's it. There's nothing else that I can do. This addition in here makes it so I can't simplify anything else. It's pretty much done. Okay, so if you're asked to condense, this is what we're looking at. We're looking at starting with something. Let me separate these out. We're looking at starting with something that's big and separated and using our properties to make it all into one logarithm. All right. The last thing that we want to look at is change of base. Right, so as I was saying, on your calculator, you don't want to see that, on your calculator, this log button, all that it will do is log base 10. That's it. It's just a log base 10 function. Whoa, come on. Why are you so blurry now? Focus thingy. There we go. It's just a log base 10. Now, there might be times where I want to actually be able to figure out, okay, what is log base 2 of 7, right? That's a question that I might have. I have no way of being able to figure that out using my calculator. This isn't a nice, perfect one like what we've looked at so far. This is going to be some decimal, right? If I wanted to, I could approximate it. I know it's probably going to be somewhere between 2 and 3, right? Because 2 squared is 4, and then 2 cubed is 8. It's probably going to be closer to 3. So maybe like a 2.7, 2.8, something like that, if I wanted to guess. But if I want a decimal approximation for calculations, then I need to have a way to do it. So the change of base formula, it tells us that if I've got log base A of m, that's the same thing as taking log m divided by log A. Notice with these ones, these are both base 10, which is great because I can actually plug that into my calculator. So what I could do with this log base 2 of 7, I'm going to have it be log 7 divided by log 2. Now I can plug that into my calculator, right? My calculator is probably different than yours, but that's okay, right? You can figure it out on yours, and if you need help with that, you can always email me and I can help you figure out for your individual calculator. So log 7 divided by log 2, remember there's no base, and I get 2.807. So I was pretty close with my guess. 2.807. And they want us to round to 3 decimal places. Let's look at one more. And let's say I've got log base 5 of 46. Oh no, 46. Okay, log base 5 of 46. For me, if I wanted to look at this and guess, I know it's going to be somewhere between 2 and 3. My guess would be probably like around 2.3-ish, 2.4-ish, maybe. I don't know. We'll see. Remember, we just take our log base 10 of the top divided by log base 10 of the bottom, right? So on a test, I would ask you to use the change of base formula. I want to see this. I know that there are some calculators out there that have the ability to change the base of that log, but that's not what I'm testing you on, right? So I'm going to have log 46 divided by log base 5, 2.379. Notice, rounding, we have to pay attention. Use those proper rounding techniques. If I've got 2.3788 and I'm rounding to this one, we look over here, this makes it go up. I know that's kind of elementary stuff to go back to, but rounding is something that a lot of people don't do just out of pure laziness. All right, so hopefully this was good for 10-4, and it should be everything you need to get through it. Remember, be checking your answers, working through these. Let me know if you have any questions. And I miss you. I hope to see you soon. Have a wonderful day.